Welcome to Episode 10, Rocket Car. Here we use our software to enhance basic physics. Our little rocket car holds one crouched person and thrusts for around 10 seconds. It accelerates from a standing start to around 30 meters per second. We will ignore rolling resistance and air resistance for this episode. But on our second run of the rocket car, we will include loss of mass for the whole car and rider as we dispense thrust. Over the next couple of episodes, we will bring air resistance, gravity and curved flight into our motion problems. We start with the formula force equals mass times acceleration. But in our model it will be acceleration equals force over mass. The formula instantly hints that a tiny underpowered car of mass 3 and force 3 will pull away from a stoplight with the same acceleration as a gigantic truck with mass 100 and force 100. It also shows that to get twice the acceleration, you can either double the force or cut the mass in half. Once we have divided force by mass, we put our acceleration into the first account of a two-account chain for straight-line motion. Our first account takes in acceleration and puts out velocity. Velocity goes into a second account and total distance comes out. Our third account is for mass, so we have the option of losing mass during the simulation while we dispense thrust. For the first run, we turn loss of mass off by setting the multiplier in front of it to zero gain. If we want a reduction in mass, it will only happen during active thrust time. Here is our signal builder that will provide 10 seconds of thrust. I think we are ready. Run 1. No change of mass. We start with no initial velocity and a displacement of 0. We apply 600 newtons of thrust for 10 seconds. Our velocity rises from 0 to around 30 meters per second. Displacement shows a curve during acceleration and then a straight line during the coast phase after 10 seconds. At 60 seconds, we are about 1,650 meters downrange. On the second graph page, we see steady acceleration on the top trace and no loss of mass on the bottom trace. Turning on loss of mass when we thrust. We will keep our nominal thrust of 600 newtons for the car. For each second of thrust, we lose some of the total sled mass. Fuel out of the tank, expelled by the engine. Run 2. As we lose mass, we see an increase in acceleration by the end of the 10 seconds. On this lower trace, we see the mass of the car come down from 200 to around 170 kilograms. Do we get a bit more final velocity because of the loss of mass? Yes. We finish closer to 33 meters per second. See you next episode for Skydiver. Here we add gravity and air resistance and changing air density to the model of an object moving in a straight line. Scilab is software buy-in for the world's community. Help them with dollars, publicity, and contribute code. TTS Voices copyrighted 2014 and licensed by LinguaTech, GmbH. Visit them at linguatech.de. Text and graphics copyrighted 2019 by William Rhodes Design.